Part 2. Perform arithmetic operations on functions. Suppose f and g are functions and x is in the domain of both f and g. Then the sum of f and g, f plus g, is f plus g of x equals f of x plus g of x. So note this notation that if I have f plus g of x, that means I take f of x and add that to g of x. The difference, or f minus g, so f minus g of x is f of x, subtract g of x. The product of f and g is f of x times g of x, and we can write that as f times g of x. And the quotient of f and g is f divided by g of x, or f of x divided by g of x, provided, of course, that g of x is not equal to 0, because we cannot divide by 0. For f of x equals 2x minus 1, and g of x equals 2x squared plus 1, find f plus g of x. So f plus g of x equals f of x plus g of x, which in this case, f of x is 2x minus 1 plus 2x squared plus 1. And then we can combine any like terms. So we have 2x squared plus 2x, and minus 1 plus 1 is 0, so that part goes away. To find the domain of f plus g of x, we look at the domain of f of x and the domain of g of x. So f of x is 2x minus 1, and in that function, x can be anything, so all real numbers. And same with g of x. G of x is 2x squared plus 1, and x can be any real number there. So our domain in interval notation would be negative infinity to infinity, or in set builder notation would be the set of all x's such that x is an element of the real numbers. For f of x equals 2 divided by x minus 1, and g of x equals 3 divided by x minus 2, find f minus g of 2. We can find f of x minus g of x, or f minus g of x, would be 2 over x minus 1 minus 3 over x minus 2. So to find f minus g of 2, we substitute 2 in for all the x's. So we have 2 over 2 minus 1 minus 3 over 2 minus 2, which is 2 over 1 minus 3 over 0. Notice this is not defined. So f minus g of 2 is undefined. So what is the domain of f minus g of x then? That would be the domain of f of x combined with the domain of g of x. So for f of x, we know x minus 1 cannot be 0 because that's in our denominator of f of x. So x cannot be 1. And the denominator of g of x is x minus 2, so that cannot be 0, and x cannot be 2. So x could be anything except for 1 and 2. To write that domain in interval notation, that would be negative infinity to 1, and then 1 to 2, everything between 1 and 2, and then 2 to infinity, everything after 2. So all real numbers except for 1 and 2. For f of x equals the square root of 7 minus x, and g of x equals x plus 2, let's find f times g of 3. So f times g of 3 equals f of 3 times g of 3. So f of 3 would be the square root of 7 minus 3, and then times g of 3 would be 3 plus 2. So we have the square root of 4 times 5, which is 2 times 5, or 10. So f times g of 3 equals 10. What is the domain of f times g of x? That would be the domain of f of x and the domain of g of x combined. So the domain of g of x, we can take any real number and add 2. So that domain is all real numbers. But for f of x, square root of 7 minus x, the square root function has a domain of all non-negative real number. So we can take the square root of 0, or we can take the square root of a positive number, but not a negative number. So whatever is inside the square root needs to be greater than or equal to 0. So if I add x to both sides, I get 7 is greater than or equal to x. Or if I switch that around, I get x is less than or equal to 7. So my domain is negative infinity to 7 with a closed bracket on 7 because 7 is included in the domain. For f of x equals 2x minus 1 and g of x equals 2x squared plus 1, find g divided by f of x. So g divided by f of x means g of x divided by f of x. So g of x is 2x squared plus 1, and f of x is 2x minus 1. If there was anything we could simplify, we would, but there are no common factors in the numerator and denominator to cancel out, so we can't simplify that. To find the domain, we have to look at our denominator again because we cannot divide by 0. 2x squared minus 1 cannot be 0. Add 1, and we get 2x cannot be 1. Divided by 2, and we get x cannot be 1/2. So our domain in interval notation would be negative infinity to 1/2. And 1/2 to infinity, every real number except for 1/2.